I'm Sig Mandel. I started organizing this chat, and then I asked Carlos to join me. I've worked in programming for a long time, and it's been my hobby since I was 12 years old. And well, like most programmers, there's been a big change in how we build products now. And I felt the change in a much bigger way since maybe January of this year. Maybe started in September of last year. And Carlos also has been through something similar, so you can present yourself too.
Okay, sure. I'm Carlos Piñan. I'm a software engineer. I worked at Meta for years. Just until recently, I decided to move back to Peru. And well, I'm taking my 2 months of holiday just to rest. But at the end, I decided just to keep going on all this AI change. I just say all the last year, I've been working overall with AI tools on my daily basis to the point that I was doing more like business work than development work, and also in parallel architectural work and some other stuff. But overall, it was agents, coordination, and some other stuff. Similar to you, I code since several years ago. I love to code, like games, apps, and some other stuff. But I'm also going to more the cloud into the cloud world because I worked with that before, but now I want to go deep in that and properly learn all the concepts. Pleased to meet you all.
Great. And I see more people joining. That's great. And what, well, for me, what started happening is that I was able to have the AI write code very fast. And at the beginning, it was chunks that you would copy and paste, and then it could do a whole file, and then it could modify many files at the same time. But it would quickly become a mess, right? And in the past months, really, all the effort that I've put to build some sort of a control to this has been on that, on making the AI, the agents, write correct code, investigate why it doesn't do so sometimes, and arrive to some conclusions. And then the software that I've been building is around that, right? Around how agents behave different than humans, and how that affects the software development cycle, and then how one can synergize with them, right? So in that sense, without having to say anything secret, how was your experience with that in the past months?
Okay. In the past month overall, I've been working on my personal projects. So, just quick context: after leaving Meta, where I had like unlimited tokens, I decided just to keep going on my personal projects. Of course, I couldn't take anything from Meta on how I set up my rules, my skill, my agent, so I had to do it from scratch. And I started again like in the last month from scratch again, just using open code at the beginning, with because I was running out of token really fast with Cloud Pro. At the end, well, after adding some of the popular repos like Caveman and some others, I was able to have something working and all my agents that I have with open code overall using DeepSeek and other models. I mean, I have something working, but it's only for myself right now. Yeah, it's not because it helps with my personal project. Before that, similar as you, I was at least the last year when I was starting, I was just using some of generic code, copy paste, and then be like very careful at the beginning. Like, okay, this is not working. This is just hallucinating. I don't trust this code, but that has been evolving. I think it has been nice for myself to see that I was able to change the way that I think in terms of AI. I'm still in work in progress, but I think it's far better than one that the last year.
Yes, being able to spend all the tokens you can is great.
Yes.
uh, so it where I work, that has been like one of the best parts, right? Having a basically unlimited
Hmm.
tokens. I mean, there is tracking, but just so that it doesn't get out of control or it's justified.
Hmm.
Uh, but it allowed me to experiment a lot with how fast one person can go, right? And
Exactly.
it has been a very interesting experiment because first I started to uh, work towards having it write correct code, modular with best practices in software architecture, in how it tests it, right? It has to be testable, in how it uses Git, because also some people can write great code but don't use Git very well, which is a
Hmm.
tooling thing, right? It's not a programming thing.
Yes, exactly.
And many other tools, right? Like a Puppeteer to take screenshots and many things that are becoming more and more standard. I've tried to put it into the same harness. But then once I was able to do that uh, good enough, I started to work on having it go much faster, but keeping the same quality, right, and safety.
Hmm.
And that's when I had to start to ask permission to my boss to uh, uh, get my limit higher and higher, right? Because we all start with a certain limit for safety, so there are
Hmm.
alerts and such. But then you can just say you can look at the dashboard and say, hey, I'm getting close to the limit. Please double it, right? So I had to double it a bunch of times.
Oh,
Uh,
nice.
but it was worth it because at the end I realized
Exactly.
that
Yes, if the
it,
return of investment
yes,
is good, so.
it would scale almost linearly. It's not linearly because we can talk about that, but I still think
Hmm.
that time is also not money. I mean, time is money too, but
Hmm.
it's worth it just as much as to write something correct. You also have to write it quickly,
Yes,
right?
exactly. I think
Uh, if you can write it twice as fast, then it's for sure it's okay to pay twice as much,
hmm.
right? Uh, I mean, you can pay the same, but in the half the time. So you end up paying that person, let's say, twice as much per hour, right?
Hmm. I,
But you end up paying the same for the whole implementation. And I think that even if it will be more expensive, it will still be better because you got it sooner done, right?
hmm. Yes, I think it's all about the trade-off. I mean, if you are having great results and you need more, I think it worth just to have more, like in this case, increase the limit so people start to deliver more. I think now with this AI era is more about how many things you can do in parallel because at the end, yes, I think overall what was happening at the beginning, I was trying to follow the code. But now at this point, when you are just generating thousand lines of code, not and also changing the business rules, adapting the plans, it's already hard to keep going with everything. So as you mentioned, if we have a proper skills harness and proper rules and everything is AI ready, now, checking the code is something that, okay, you're going to do in some very specific cases, but now, like, okay, if it has all my rules, it has all my practices,
Mm-hmm.
I mean, do I really need to check all the code?
Yes, exactly. Right. I think um, you don't need to check all the code visually
Hmm.
as line by line, but you have to
Yes.
have, like you said, a really good harness that ensures that the code was checked in a fair way, right?
Yes.
Um, and well, talking about that, I mean, that's, I think, a central part because the AI can write a lot of code, but if he doesn't test it well,
Mm-hmm.
and by test, you can also test the quality of the code, right? With some techniques, then the AI doesn't end up writing that very good code, right? So you have to ensure that at certain key moments, certain tests are run, right? And
Exactly.
and also one thing that I've noticed, and one thing that has been central also to this harness that I've been building is you have to have very good documentation,
Mm-hmm.
right? In the traditional software, you can be sometimes a month or more behind in the docs, but you can also talk. You always can talk to your peers, and you also have a lot of stuff in your head or about
Mm-hmm.
the software, and you can talk in Slack and ask and code, and you don't have to, or maybe never read the docs, or maybe there are no docs.
Mm-hmm.
But with AI, I think one day that you don't get the docs up to date, that day the AI could hallucinate,
Mm-hmm.
right? Uh, because even each turn and each agent job has a budget tokens, and you cannot think forever. So
Mm-hmm.
if it doesn't find quickly what it wants, it could hallucinate it. And also, if it doesn't find what it wants, it also can hallucinate it.
Yeah,
You,
yes. I also I think as you mentioned something that I now that we are talking about hallucination is also about sometimes something that you mentioned that instead of accepting that the model doesn't know anything, just invent something from scratch. And instead of telling you, okay, yes, I don't know, you just okay, yes, I have this option that maybe is not related, but sounds nice and convincing.
yes, yes. Ah,
No, no, yes, and with that, I think I recall one of the things that I did on my time at data was I also started to create rules. Overall, that was happening more to me with Opus 4.8 or 7. I don't recall which one, but I had to add specific rules on my agents on the dot cloud to ensure. Okay, please, if you don't know, just tell me. Like,
yes, yes. And that's also um, your audio sometimes gets muted. I'm not sure why.
oh, really? Okay,
Not
maybe it's
now, but
okay,
a
maybe the microphone.
couple times gets disconnected maybe. But it
Hmm.
was only very short periods.
Okay.
So I wanted to show something related to that.
Hmm.
Uh, one issue that I might have is that when I switch the window, because the meet window that we have won't be in view, your audio might not go through.
Okay.
We'll find that. But when
Mhm.
you want to talk, I will switch the window back.
Okay, excellent.
Okay. So one thing that I will show a bunch of things here on how we do the setup for coding,
Hmm.
and that can be seen here. So first, I'll explain. Many people haven't seen this way of coding before. I think this came from how Google was coding internally to code in a safe way and to make it easier to developers to code without having to use an actual physical machine. So this is a VS Code window, right? But it's inside a browser, and that's a service that Google Cloud has, right? So we at work use that, and you can create many windows and run, in this case, is Claude code, right? And so what I've been building is on top of this system that already is a very secure, very practical way of having many repos on these virtual machines that never lose their disk, basically. And you can access it from any machine, like it would be a remote desktop. On top of that, I built this system that tries to add all of these best practices and guide the agent in this harness to produce good code, quality code, and fast, right? And it's oriented, at least for now, to like a tech lead level developer that can handle basically the whole project, uh, and maybe accompanied by one more person. It could be a junior, could be a mid, a senior, but you can also have a traditional team with 6, 7 people, but and it works. But you need to have a tech lead level person because you will see that there are many decisions that that person has to make to keep the system healthy. So one this is one view, but really the system full view is more like this. Like when you open this machine, automatically it opens this dashboard, which is the new IDE, let's say, where now the developers code. And they can see, in this case, I have some parts in Spanish, but you can change the language and stuff. And what it shows is like the flow of from idea into implementation and really post-implementation. And this helps you keep track of all the tasks and plans and sessions that you are doing as a developer. On the top part, there's a quick view of what's going on with the repo. Each team member has their own view. This runs as a server inside the same machine that is running this, the open code. And then they have, like the new agentic development workflow, where you can have ideas quickly mapped here. And these are like loose ideas. There's no validation. You can just add them, classify them. But then you can take one of these ideas and say, convert it into a PBI or convert it into an instruction to create a plan. So what it does is it takes it down, either into the board, which is like a Jira board or an Azure board, it's connected to it, or into a plan. The board is more like a traditional step. In the case where you are the PO and the developer, you don't need a board, but otherwise you can use it. But then the interesting part is the plans. Well, the one that I skipped, the GDocs, is more like a tool. It lets you connect the repo, Git, with Google Docs. And that way you can produce a Markdown document, synchronize it with Google Docs, share it with the PO or with the stakeholders. They make comments, modify, then sync it back into the repo. And all those people didn't have to interact with the repo, which they never do. So it's a way to incorporate those actors, let's say, into being able to send feedback into a repo. And then the developer can use that to, for example, create a plan or create a backlog item in the board. In plans, there are some interesting things that help developers a lot. I say that because I've used this system to build itself, right? And it's a pretty big system. Took a couple months to build most of it. So it's been a very quick, intense build. And it has helped me a lot to get myself organized and to ensure that every plan execution has all the things that we've talked about, right? The quality, the checks, that is well written, that it does what it's supposed to do at the business level, at the feature level, and that also the documentation is updated. If we see the plans, we can see that there are some pending, some in progress, which right now it's executing, and almost 2,000 plans executed on this repo. Each plan could be something that a developer takes 2 hours to do or 20 hours to do. So there can be various sizes. And what the plan does is ensure that the feature is well understood and that it tells the system how it would code it at the software architecture level. So it's not a spec, right? The spec is more for the business, for defining the feature, but here is more next level. You have the spec, but you want to make a plan to how to code it. In that part, I don't know if the listeners have seen this guy in YouTube become a YouTuber that is a really good coder and such called Matt Pocock. He has a very popular repo. And one of the skills that he has is called Grill Me. If you guys haven't seen it, you should try it. Because part of the planning is based on Grill Me. It's a step during the planning. And what Grill Me does is forces the AI to like walk the tree of all possibilities at every coding step. Right, so it covers not just the happy path, but also all the errors that could happen during that happy path to handle the errors. The AI tends to hide the errors, right? Because that way it gets their job done. So in this case, no. In this case, it forces you to think and it asks you many questions to be able to get answers from the developer on what decisions you should take, right? Whenever the AI can't decide by itself. And that's the key part of the tech lead, because that's the part where you end up making sure that the software architecture is correct and that the AI also understood correctly the task. So you guide the AI into making the correct plan, which sometimes can take 5 minutes and sometimes can take an hour because it asks you a lot of questions. A few days ago, I think a couple of weeks ago, Matt Pocock updated its skill with a version 2, which is great because now it's smarter. And instead of asking you one question at a time, it shows you like 5 or 6 questions with their predefined answers, default answers, and then you can just say, go with all recommendations.
Mm-hmm.
Or just say, everything yes, except this one, like that. And that's making it make plans much faster. Yeah. Have you seen anything like that in your experience, Carlos? Or the way of planning for work or trying to refine a feature?
Yes, in general, so the development life cycle, or at least this last year when I was on Meta, was overall focused on all the planning, try to just spend a lot of time just in planning and unblocking features overall. So it was more polishing what we are going to do, split into small development phases, tasks, and also being able to split not only into like sub agents, also with other engineers, because at the end it's all the team that is working, it's not only myself. So yes, I spend a lot of the time on all the planning and all the architectural part overall. I think one of the most important skills right now with the AI era is all the bases. Like uh, what I mean is all the knowledge on software design, all the architectural patterns, all the algorithmic concept, because you need to understand what's going on if it's good enough. So yeah, I mean, it has changed from knowing like something very specific to understand how it works, everything, like at least okay, how it's working this, how I need to plan it, and how I can just, because I'm not going to learn everything, right? I need just to understand the basis, and have a good foundations.
Yes, yes. I mean, that's also a big change for me because in the past I had many ideas that I wanted to code. And this really started to happen farther back, right? Because even though it wasn't coding everything, it could tell you how to code it. and it
Mhm.
could also do the setup of whatever tooling or new language. I did some things in Rust, and then
Mhm.
using Cargo and using it. I would never touch it before because it will
Mhm.
be so many hours of frustration getting your machine set up
Exactly.
that you wouldn't do it. And now, you have the machine, the 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 Claude code or Gemini or whatever is running locally in the machine, and you say, create the scaffold it, install whatever it needs.
Mhm.
You still
Ac-
approve everything, but it
mhm.
does it. It just does it, and then you're in 10 minutes. You're ready to even deploy a new project, right?
Exactly, and I think that's the game changing because as you mentioned, like so everyone have like plans, but starting all like solving all the initial step, just polishing the plan and all the boilerplate. Yes, that part is like okay, is the when you say okay, I want to do it, but I don't want to deal with all this. But now with AI, all that boilerplate stuff can be done really quick. I was talking with a friend recently that they started to use Cloud Code, and she told me that yes, I didn't know anything about playwright and this stuff, but with Cloud, just help me to make all this setup just in an hour. But and it was okay. It's a game changing, right? It's like from not knowing anything to have already your all your setup and your basically all these scripts running by yourself, by themselves, not even yourself. So I like that. So I think it's more about learning how to handle this, how to properly like update the context on your mind because it's more something that's working on your mind on how to handle all this stuff because now there are a lot of repos about hey you can just put this onto your AI, you can just put this and now every day there is like 10 times more than the day before.
Yes,
So
yes. So it's easier and easier to get started on a project. But one thing that I focus a lot is how do you keep going?
mhm,
Because you know, with a Lovable or Google AI Studio or all these um, online tools, you can go from a sentence into an app,
mhm,
and it works. And you could even handle security and things were small things, but then it gets quickly out of control.
mhm.
Uh,
Yes, that has happened to me a lot.
also, that's part of the focus that I've had a lot on this, right? So going back here,
Mhm,
if we have a plan that covers everything, then even the files that it will change, then it's much easier to ensure that it will code it correctly when you execute it in a session, right? And some things that I found for these plans can be seen also in these filters, right? Because first,
mhm,
the system can have plans for the product because the system installs on a repo, can install in many repos. So it can be for a feature in the product, or it could also be a feature for itself, because the harness also evolves over time. And that's
mhm.
something that I wanted to talk later because it self updates,
Learn.
right? It identifies improvements that I can do automatically, and then proposes plans, which end up here, right? So there are plans created by itself or plans created by humans, and also for different parts of the product. So in this case, in this repo, there are these domains. It's like a monorepo with the backend, the front end, the agent system, infrastructure, and such. It also classifies with risks, A, B, C, D. This is something very interesting that I've had from the beginning because I wanted the system to be autonomous where it can be, and also humans to be less controlled or more controlled where it can be. So in the system, if we go quickly in the setup, you can see that you can be a tech lead, or you can be a PM or a developer or a PO. But if you then you can say, okay, the trust is senior, junior, mid, and according to this, right now I'm like this. Uh, but if I would be a junior, it wouldn't let me execute a plan that is risk B or more. Or if I do, it would make me do a PR so that the tech lead uh, sees the outcome. And also even creating a plan, right? I can create plans, but uh, I cannot execute a plan if the plan itself is not, it doesn't go through a PR. But only if the risk is high enough. Right, so a junior could create a plan, a risk A plan, which maybe is changing some text in the front or changing, things that there are many ways that it measures it deterministically and not deterministically, and then it says, hey, you have to go through this route or through this other route according to the risk and the experience level of the user. So a tech lead can work very fast because it puts you very small, very little gates, but a junior has more gates and it has to go a little slower. But that's so it's safe, and also to not overwhelm the tech lead. That's something that is very important. I think has been happening for a while. Tech leads are overwhelmed with trash vibe coded PRs, and before writing code itself, the speed of writing code was also a way to stop juniors because they would code slower, and so tech leads would get less PRs from juniors. But now the juniors code even faster because they skip many gates, many checks that the seniors do. And so they end up sending a lot of PRs that are trash. And then the tech lead is overwhelmed by all these PRs and can't do his work himself. So that's why this system puts a lot of checkpoints into juniors' work. So they go slower, but safer, and then the tech lead is not overwhelmed.
It's a way to limit the speed, unless in a way to say so. Because yes, with all, I mean, it's a way to limit the speed of the junior engineer. Because yes, if now that with the AI era, they can do a lot, but if there's nothing that is controlling, like it can just generate more tech debt than really.
Exactly, it's more tech debt, right? And that's, I mean, the junior is there more to learn. It contributes 20% and learns 80%, right? But if nobody controls them, they could start contributing 80% of trash and only learning 20%. So the idea here is to invert that. And well, that's one of the things that I've been focusing. So one interesting thing that happens with plans is that once you have them created, or the system creates them, and in this case I have 36, and it sums about 200 hours of work, of pending work, I can start executing them in parallel. And how does that work is because each plan has declared their paths of where they will work, which could be directories or specific files. There is what's called a claims dependencies system behind the system that can deterministically build like a graph and say, hey, these plans can run in parallel. They don't touch the same files. Right? And that's what makes it be able to code really fast. And it has some tools to help you with that. Because like right now, I have one plan in progress, but then I can say, okay, which other ones I could execute? And then it gives you this tool, right? When you can say, okay, I can start, well, let's say I want to work on things on the dashboard. Well, these are the ones that are about the dashboard. But if I leave it open, I can say, okay, let's say pick this one. So I will add it to my list. Okay, then let's pick this other one. Add to the list. So it helps you plan what to pick. There's a lot of things here to help you plan. And then once you have picked them, you can just say start, and it will appear here in progress, advancing in parallel. Uh, Typically, you can do 5, 6 things in parallel. But it wasn't just about having them not modify the same files, but also there was an issue that they are sharing the same machine. So how does so far like the traditional way to solve that? First, the traditional way to solve coding many things in parallel is to use Git work trees. I don't know if that has been a practice in Meta or in your previous.
Yes, we had like something called like, well, basically it was the same because server on demands that just creates a new instances every time to not overload a single agent. So we have like small servers being created in parallel whenever it's needed. So, but yes, that was one advantage that we can just keep running servers until we have like something saying, okay, you are just creating several servers, just wait there. So it was a way just to limit our limit just not consuming or burning too much machine.
Yes, but there is an issue with that, okay? But that I didn't like much, and it's that once you start adding a lot of tests as you add more code, and in this case, it's not a typical repo because this is the repo of the system itself. But this system, like I said in the YouTube, has over 1,000,000 lines of code. And as it has been writing those lines of code, has been adding a lot of tests. And right now it has over 20,000 tests. So if you want to run 20,000 tests,
yes, that was exactly what was happening.
And that happens in any software system that becomes a little bit bigger. Maybe not even 20,000, but the system doesn't run the 20,000 at the same time because it knows it's smart to know what test to run. But still, it ends up running 1,000 tests, 500 tests, and then you have many work trees running a lot of tests, and they are pointing at the same binaries in the node modules.
Okay,
or it becomes a little messy. And they don't talk to each other, they don't see each other. And then what's really happening is that if you try to be really productive and do a lot of work trees at the same time, you will end up with a merge hell, right? With AI, it's now better to deal with those, but you are postponing the program. You're getting productivity, but postponing the program. So one thing I experimented a lot, and now is like my default mode of working, is that these parallel sessions don't use work trees. You can if you want, but what it does is because it controls the files that it will change, the hardnet itself doesn't let a session touch files that are not part of their claim.
No. Okay. I recall we discussed about that, about the claims.
Yes. So that's a protection, but it's not just a protection that fails. Right? If the agent tries to write and it fails, it tells it why it failed. Hey, this is another session working on that. And one of the things built on the system is also a messaging system on top of Claude Code. It's not the messaging native in Claude Code, which allows to broadcast messages to all the sessions or contact a specific session, and it will reply to you. But the developer can see that happening here, like in messages, and then you can say, what has been going on. With replies, there are some that, because it's archiving in this machine, we don't see that many. This is not my main machine. But on each machine, it has the whole full history of what has been talking to other agents, so they can coordinate. Like if the agent discovers that it needs a file, but another session is working on it, or because it knows what each session is doing in parallel, it says, hey, I'm going to affect it somehow, even though I'm not changing its files. It tells it, and they coordinate. So you never end up with a merge hell.
Oh, nice. I have a few questions on this because I mean it's really interesting. I want to understand, for example, for the people that is here, this is a great agentic coding system. But when you start to design this system from scratch, I mean, because I can imagine a lot of people want to integrate something like this in their like daily basis, but it's hard, right? Because you mentioned that you spent 2 months building everything. Yeah, and it's a lot of work. But for anyone that wants to start to look into agent coding, what do you recommend to start? Because here you already have plans, roles, pending, and
Yes.
self learning in loop, right? So.
Well, this started as a regular repo that had skills, right? And we can see that here. I'll show you. Well, first I have to ensure that we are looking at everything, all here. You're not looking at my screen. There. So in the view, it separates if you want to look at the system agents or at the product. So I'm putting all, so we can see that. And then if we go into reports, we can see that if we turn on all of the categories. Okay, so the repo was born with 0 lines of code. There was a refactor. We redid the product in these months. And then it started growing like a regular repo. And it had no agentic system. It had only skills. And we can see the skills here. Really.
Yeah, I saw it somewhere there. Agent skills.
Agent skills, this. Okay. So it's been growing. You can see it. But there were always some skills, like in week 9, you can see some skills. And the skills grew and grew and grew. And then what we wanted to do is take those skills and make them reusable in other repos. Right? And really the main skills and the heart of the system is a few skills. In fact, if we go to, now that you're asking about skills, we can see a skill graph, okay? And the main skills are the dev workflow gates. There are many others. We don't have time probably to look into them. But in here, we can see, let's see if I can zoom a little bit better. The main ones are, there is a skill to plan, okay? And we can see here, plan. And then while planning, it knows about software architecture to be able to do each box is a skill, right? But the planning guard skill knows about many concepts, about the workflow itself, about how to use Pro, which in this case is Fable, to do a super plan, a super adversary style plan, like challenge, the very strongly challenged plan. Then it knows about how to improve the code's architecture, and that way it can modularize it while planning, and so on. There's Grillemy, right? So not only at the beginning the skills were like islands, but then one of the first things that I did is to have them like this, right? They know about each other, and the system knows what skill depends on what other skill. And somewhere there's a graph that we can see there, like a 3D graph about them. But here is a better representation of them. And each of them, like if I click on them, plan guard, it tells you, right, what it does, its relationship, who uses it, and share core means that any repo will inherit it when it gets installed. There are some skills that are for the product and just for the product, and others that are for any repo that gets the system installed, right?
Nice.
So that's how it started, really. I had a plan guard with the like my own version of Grill Me, that then I improved it a lot with Matt Pococ's version, and I put his name, like the Grill Me, it wasn't called Grill Me. And then after that, there is a code guard that we can also see it. Here it is. Right, also knows about a few things that also plan, like they share the code architecture. No, it's connected to plan guard and also to code guard. And then I would do the workflow manually. I will invoke the plan skill, and it will create a file. And then I would invoke the code skill and say, no, code this plan. And then I would tell it to run tests. And then when I would tell it to update the docs. And then, right, so I would take it by the hand. And then I started to make workflows and say, hey, just do the workflow, right? And then the workflow knows how to first do the plan, and then do the code, and then shoot the tests, and then do the evidence, and then it knows all the steps. So then as a developer, you only say, I want to do this feature, and it will suggest, it will tell you, okay, let's do a plan. Then, okay, the plan is finished. You want to code it? Yeah, code it. And then when it codes it, it does everything. It doesn't just code. Code, create tests, code reviews, take screenshots if needed. And then it does some like agentic best practices, like sub agents that don't see the code or don't see how the code was made, and just you give it the diff, and then does a review without having to see the thinking of the parent agent. And then it does a really clean review, like a blind review, because otherwise it gets influenced by what the coder thought. Right? So all those techniques are combined so that you end up following all the best practices of the software cycle, right? And we can see that here too, right? If you see the SDLC, it really takes you, let's see if I can zoom it. It takes you from an idea, then into the design of the idea, which is part of the plan, then into code it, and each box here is something that participates on that step. Right? Then you go into the test, then you go into the review. The red ones are obligatory. They are deterministically obligatory, right? That the harness verifies with scripts that you actually did all of those and that the outcome was correct. Otherwise, it doesn't let you go forward. Then you deploy, then you have operate, including incident responses, trace analysis, like Langfuse, performance profiling, here's Langfuse, analytics of the log. So there's a lot of observation, traceability and observation to see that it really is doing well. Oops, sorry. Then there is maintenance, also many maintenance of the system itself. And this is the interesting part, because it can, if we go back to, let's open it this way. So if we go back to the dashboard, there is a part of operations. And that's where you were talking before, right? Not only the learning, which is here, but the system can keep recurring tasks of, for example, to maintain itself, to ensure that there is no drift between the code and the docs, to ensure that there are no broken links, to optimize the graphs of the documentation. There are some memory diagrams that needs to update as the code changes. So this is where the recurring tasks go. I have 6 over there. And then deferred tasks is really interesting, because what happens is, because the system is programmed to follow the plan strictly. If during coding and even during planning it finds things that are interesting to code, to implement, it doesn't add it to the plan, or it doesn't just start on a branch coding it, even if it's something good. What it does is it keeps a record of all of those things, and then at the end it tells you, hey, I found all of these things, I can add them as deferred tasks. You want
Oh,
to?
that's nice.
Which ones do you want? Right? You can have a conversation about them, but it doesn't lose them. But it doesn't destruct the agent. So then you can say at the end, yeah, queue them, and it will queue them with a priority, like, and with a date. So then the system knows when to run them. And you can also decide, hey, don't queue them, just execute them, right? Make a new plan to do those. So close the current plan, you're done, and now make a quick plan to finish up those. But it's sure to separate, because you don't want to mix functionality too in the commits, right? You're committing only what the plan said to do.
That's nice. Now, one question regarding this deferred task. So, for example, you already you have a plan. The agent is doing the work with the code. So when it finishes, these deferred tasks are part of the learnings that it says, okay, I found this, that this can be done in this way, or something to improve, but it's not high price, for example. But it's basically a something that the system found out by themselves and tried to propose it.
That one goes in a separate place, right?
Okay.
So, but it's also a queue, and what you're saying is, like, maybe a better way to explain it is work queues, right? So if we open work queues, there are, I think, 12.
Okay, there is the work queue. Okay.
And these are places where work goes, right? So either goes as a brainstorm, and each member of the repo has their own brainstorm file, really. That's how it works. Like, really, the entire system is files, right? That's something that I haven't mentioned, but the entire system is fully Git, is built on top of Git, right? So the queues, the plans, the status of the progress, everything is files, right? Sometimes sharded,
like Unix.
yeah, and they are divided, right? Because they don't collide. It's done in a way that they never collide into a merge conflict between machines or team members. And so you have the ideations, then you have these findings. That's what you're talking about. I will go back to it once I. Then there's these, and these are findings. These are the plans. These are the deferred tasks that we just saw, and the recurring tasks. Recurring you can add for the product or for the system. The system comes with its own recurring tasks to ensure that it's healthy and its documentation is updated and such. There is recurring tasks that are done daily, and some are done weekly, and some are done with a different cadence. Okay? And then there's telemetry that creates in many places. And that's what you're saying. It's either telemetry that is done deterministically, and then it's done later during a pass on a recurring operation. It will detect a pattern and say, hey, we need to fix this or improve this. This is more mechanical. But then there is also that while one of many, there are many similar recurring tasks, but one of them, what it does is analyzes the actual Claude code sessions of the developers. Right? So I have like thousands of sessions, and it's really that data is super valuable to mine, right? And there is some mining that it does daily. And then there's what is called a dream cycle, which is a deeper analysis that it does weekly. And then it goes through all the sessions, and it says, hey, this script that it called failed, or it called the wrong script, or it hallucinated here, or it tried 4 times to do this task, and then it could have done it in one step.
Mhm.
It finds all those things and creates findings. So these are this into the improvement cycle, and those findings automatically create plans.
Oh, nice.
But nothing changes until the tech lead says, "Hey, I like your plan. Execute it."
Mm-hmm,
Right?
nice.
And even before that, it says, "Hey, I have these findings. Let's create a plan." And the tech lead can say, "No, don't create it yet.
Mm-hmm.
But let's see it in 3 weeks." So it will do a deferred task to remind you to,
Ah,
right? You can also do
okay.
that. While you are chatting too, right? You can also say, "Hey, and this part, put it in my brainstorm file, or put it as a deferred task, or put it in my notes, so it can put things in the right place to not lose tasks, but also to not distract the agent. The agent, you don't want
Yeah,
to
that
distract it.
otherwise it will just go into the branches instead of focusing on what
Yeah,
has
it
to
will
be
never
done first.
finish, and
Yeah, exactly. Just going.
he also contaminates the data.
Mm.
More things to validate, more things to test. I mean, it goes that it was unplanned, literally, right? So if it's not planned, it will push as much as it can to do a deferred task, and then you choose it to execute later.
Mm-hmm.
This is not typical to have 549 overdue tasks, but the good news is that only 10 are high priority.
Yeah, yeah. So that's the important thing. If only
Yes.
10 are yes, the
So
other
the
are
system ensures to execute the important ones. There are also very few medium ones, a lot of low priority, because also it's not typical to only have one developer. Like I have had no help. So I've been focusing on improving features, and
Mhm.
most of those overdue tasks are best practices that are okay, but most are like dry, like refactor, because hey, you could reuse this code. But at that time, I'm like busy, and I'm like, only 2 or 3 users. Okay, leave it duplicated, but remember.
Mhm.
And then one day, I always say that, but one day I will like sit on a Saturday and kill 300 of them,
Oh wow.
right? But I haven't done it. But it's mapped. The important thing that it's mapped, um, and you don't get.
Nice. I mean, I have a lot of questions that because this is great overall on how the system performs. I know some of these questions I already asked you before, but I think it's also for the public. For example, when you run a task, you start the plan. How the agent decide first of all how many sub agents need and what models need, because that's more under the hood, right? At the end, it runs several sub agents in parallel to do some work depending of the complexity, but also it needs to choose well what kind of model will use, because it's not going to use Fable 5 for everything because that will be just expensive.
Yes, that's something important too, that it's done at planning time. Okay,
Mhm.
I can't open a plan. I wish I could, but it's company data.
Oh, yeah, yeah,
But
makes sense. Yeah.
right, but when it plans, one key thing of the planning is that here we can hear an example. If I switch to the other window, okay, I think I've been causing echo with my voice all this time. Hopefully, right now I just figured out how to fix it, so hopefully it won't happen again. But okay, so in here you can see this like picture-in-picture window. Right now I posted for the presentation, but usually I have many plans running in parallel. And in here you can see, if we zoom it for you to see better, there's a little line here. It means a phase. So this plan has 1, 2, 3 phases. And when the plan is designed, a big focus is placed on figuring out logical phases to code, like maybe you first code something that is a foundational code, like a little engine, and then you do the APIs, and then you do the front, connect, or work by vertical slices and do a little bit of the front and a little bit of the back. But it figures out the logical phases, and then it tries to break them into mechanical and non-mechanical work. And then basically it has three levels of work, right? Super mechanical, which internally, I mean, there's a one config file where you map the models, but right now it's mapped to haiku, to the super simple. Then this is mechanical, it's sonnet. And if it's like a reviewer or you have to think about the architecture and such, it's opus. And if it's something really hard, it uses fable. And it has those 4 levels. Right? And with that, in the plan, it specifies, right? This phase, this model, this phase, this model, this phase, this model. And it also analyzes if it's worth it, depending on many criteria, if it should run in the loop, in the same loop as the coordinator, or if it should run as a sub-agent. And that's the sub-agent, it depends. It knows how to the pros and cons. Like the biggest pro is that it doesn't see what the session thought. It just sees the output. So you just give it some input and say, work with this input. It's much little input. It uses less context. And it returns an answer. But it has cons because it has smaller context, and also, right, it can time out, and then the coordinator loses everything and has to do it again. Right? So it has pros and cons. Sometimes you want it to not see anything, especially if you want to do a code review. So you just give it a div, and the worker as a sub-agent does it, and otherwise do it in a loop. And that also limits the speed of the user, the developer, because like here you can see a red line, but you can see a black line. When the line is black and thin, it just means it's a phase that it will be handled by the system itself, and it just continues. But if you see, it stopped here, and it's because it's red, and it's because the human has to approve. And it knew since planning that was a checkpoint. And sometimes it's more of a limitation of throat code, really. Because what happens is that once you're running, I mean, each of these, like this session, we call dashboard guide. Like if you go here, we can see that session. Wait, sorry. Interesting. This is another workstation. Let's switch to that workstation. So you can see what it's doing. So in here I can say, right, it's here. Yeah, it's projecting, yes. So you can see that it has stopped. In this case, it's because it's asking for my acceptance. I have to say accept, because there is all these checkpoints for humans, right? And but it could also be because it's on Sonnet and it needs me to change to Opus. And there's actually an API that I have planned. There's a pending plan for that. It's not that easy. It's possible to control from the outside and make it change. But in reality, right now, what you have to do is say, model, change it. It will tell you, hey, change to Opus, and then you change, and you say, go, I continue. That's when it runs as a loop, in loop mode. When it runs as a sub-agent, it doesn't need you to change the model because the sub-agent can run under a pin model. And so that, there are some sub-agents in the system that run on specifically on certain models, and then that's automatic. Right. So in this case, I'm here, I can say, hey, accept, and then do this command. Right. That's something internal, but what it's doing is it accepts the plan, so it will close, and you will see that it will go away from here. This is a special thing also from the system that tells you you are in the acceptance mode of this plan. It took 14 screenshots. We'll see what it did. I don't remember what the plan was about. But it gives you information about the plan, it will close it, and then the done, what it does is it closes the session itself. Why it does that? It's because in the dashboard, you have sessions, and you have the ones that are right now being running, like this one that we just activated, and then the ones that are done, right? It shows until 90 here, but really I have like thousands of them done. And otherwise, and that was also happening to me when I was just using Claude Code, you accumulate a lot of sessions, and you never know which ones you really finished and which ones you left in the middle, right? It happens a lot, right? So that's why this exists, right? In here, you can say, hey, I have this for running. This one is actually live, so it shows me that it's live. And then it will be done because of that command that I did done. But I could also have dragged it here and say done, right? Actually, it just did it by itself, right? Because while we were talking, it did the done command. So now it's here, right? It's still active a little bit, but it will stop in a few seconds, probably finishing some stuff from analytics. Yeah, it's the end, the very, very end, right? Yeah, now it's done, right? So this is like the live view of what's going on in the system, including like this dot. It's because it produced some evidence. Let's see what it is. There it is, the 14 screenshots that we talked about. And what are they? These ones. It's stuff that it did to verify whatever I told it to implement, and it's the evidence, right? It says from which plan it is, and then the entire team can see that evidence. Yeah, it's an output. I mean, it's not just the diffs, right? You have the diffs, but you also have the visual output. And one of the interesting things of the system is that it does complete traceability, right? So it knows, because it has the session indexes, like every developer session is indexed, which has the thoughts of the agent, the decisions of the human, but it also has the screenshots that the agent took. Automatically, there's a hook that detects that it's happening, saves it, indexes to, saves it to the cloud. So then at any point, you can ask the chatbot, hey, which screenshots are the evidence for this plan 2 months ago? It will show it. These are the screenshots. Also takes those screenshots, and there is one a recurring process that says, hey, this screenshot looks interesting. Let's put it in the documentation. And it embeds it in a documentation page with the feature, talking about the feature. So that's more like to keep track of really the history of the project, right? Yes. Exactly. Right. That's a very important part, because if anybody leaves the team at any point or is busy on something else, on some vacation, whatever, you just ask the agent, right? And by agent I mean like this one, right? If we go to here, it has a chatbot, like really many chatbots that you can run, but one of them is about the system itself, and another is about the product that it's building. So it can tell you about the architecture of the code, the functionality. Like in this case, I told it, hey, tell me about how the system writes correct code and best practices, because we started the chat about that. And hey, this is what we talked about, right? It has the plan guard, then the grill me, code guard, commit guard. all of these other guards that run in the process, including glossary guard. This is a really interesting one because it forces you to use the terminology of the product, right? Like if the product says that something is a workflow, then you cannot call it a process. I, yeah. And it has a long list that it keeps growing and growing of what is the vocabulary of the product and of the system. And then it forces the bots to use it whenever they write documentation, comment, and such. So we were talking about that there is the chat, and that's also where it helps you with asking about anything from the past, right? Hey, I don't remember this feature, why it was coded like this, or why this architecture is like that. Then it will search the documents, which are always up to date. If that's not enough, it will search the code. And then if the code is not enough, because sometimes you don't know why it was written like that, it will say, hey, what plan implemented this code? It knows. It will search the plan. If it's not in a plan, it will say, hey, what sessions of what developer implemented it? And then it will go and read the session. And it finds, I mean, that's the ultimate truth, right? It's the brain of the agents, the brain of the developers is there. And it finds it very quickly because it can do this. If we go into documentation, there is like a live graph that it keeps always up to date of the entire system. And what this does is, it's kind of big because I'm putting everything together, but you can filter just the agentic system, which is the biggest one, or just the product, or just about the company where I work. It has a knowledge base. So this is a knowledge base of, there are some islands we can see, of really all the relationships between the code and the documentation and the diagrams. And the idea is, and you can see them here, right? You have links, which just says, this markdown links to this other markdown, because maybe there's an index. This happens here, right? This one, for example, I'm pretty sure is the product. Yeah, the company KB. So the center one is the index, and then it has a lot of little MD files that the index points to. Right. So if an agent finds it's on an index file, it doesn't have to read the entire index to find all the references. It can just go to the graph, which is like one hop, and say, hey, what are your neighbors? These are the neighbors. That's about links in documentation, but there's also, see also. So you have a concept, see also this other file, this other MD file to go deeper. So there's a see also. There's a drift watch. This is something interesting that I haven't seen in other products, which is an efficient way to update this graph. And so what happens with these graphing systems, like there's Graphify, for example, which is a really great open source, but it runs, consumes a lot of tokens, makes a graph, but then you change code, and how do you update the graph? You have to run the whole thing again. And that's really expensive. So I put a lot of effort into having the hooks, right? Like the harness has like 90 different hooks. And they are watching for a lot of things as the agents code and the humans answer things to know which stage you are in this SDLC, what skills you're using, and such. And so while it does it uses this graph to determine that something maybe needs to update. For example, these drift watch links, what they do is say, hey, this mermaid diagram here in the documentation, each node comes from this part of the code, Python, TypeScript, whatever. So then if I later change that Python file, the harness automatically leaves a little note, right? it leaves a little note saying, hey, by the way, maybe this diagram needs to update. So then when the day finishes and you run the recurring task for docs drift, it doesn't have to redo everything. It will find, like, there are literally thousands and thousands of nodes, but it will maybe find 10 different, like, breadcrumbs. So it will only process those 10. And it spent like 5 minutes and $1. And all right, instead of rebuilding everything from scratch, right? And that helps a lot. Of course, I mean, this navigation is really for mostly for me to verify that the thing is working. We want to see it, but really, who uses this is the agents, right? Yeah, I can click and then navigate nodes and advance them, but really, I never enter here except that to make sure that the graphs look sane, right? Like the parts, and you can filter them and such. But it's not for the human. It's more for. I mean, it's like yeah, it could be useful because then you could navigate here to a neighbor. Then like I can click. But really, it's for the agent to say, hey, this document has all these neighbors, and the branches are of this type. So the agent navigates the graph and finds information very quickly with very few tokens, right? And if it's when the agent is close to consume its budget, it will hallucinate to give you something, right? So if this helps the agent to not consume its budget, then it's a win, because you decrease the chances a lot of hallucination. And that's also something that I've had to like accept. Like before, I had to have every line of code perfect and everything. I had to view it by myself. But now I see the software more as something organic that is growing. And you just have to make sure that what you put in value is much more than the little things that could be left behind, right? There is still a lot of effort into making it hallucinate the least, right? Make the least amount of mistakes. Keep all this, like I went here because I wanted to go back to the deferred tasks, right? And there's everything at the end is not lost. It's still here, right? Because it will eventually find it, either right away while it codes or during the dreaming phases, the recurring task, it will find those little errors that it didn't catch during the review, and they will eventually get fixed. But you accept that you have some times where you might be adding code that is still not perfect. And you need to make more plans to make it perfect, well, and then you push, right? But you can have locally, it could be in a state where you are not really sure until you run a lot of tests.
Do you have like process running to try to check what part of the code can be improved based on your guidelines, on your rules, or how do you handle the self improvement of the code in this case? Sorry, can you hear me?
Yes, sorry, I had my thing on mute accidentally. So there are a lot of checks that it does. I mean, both, like one key thing about the system is that most checks are in two levels, right? One or three levels. One is in the pros of the skills, and then you hope that the skill does it, but you know that eventually it will fail.
Yes.
And then you have hooks at the Claude code level and also at the Git level that verify as much as possible deterministically, right? That the thing worked. And that includes having it write tests but then having maybe a tool that verifies that it actually covered that code in the test with test coverage. So that's something deterministic that you can do, because it should have increased the test coverage of the code after writing the tests, even if it doesn't know if it's testing everything. Right?
Mm-hmm.
It could also check, right, if it's injecting, like you can do something called a import linter
Mm-hmm.
to verify what it's importing and to make sure that it doesn't import private things. So it only uses the themes, like the schemas or whatever the app is that it needs to use, and it doesn't go over, it doesn't break the software architecture. And that can be done deterministically. Right? It doesn't catch everything, but it catches a lot of things.
Exactly.
Right?
Yes, I agree.
Then you can also automatically run, like for Python, RAF, or things
Mm-hmm.
that check styling. And the agent writes style code that follows the style guide of the repo. Like I've looked for a lot of deterministic tools for Python that I didn't even know existed before, and I put a lot of effort into making them work, right? Including tools that are visual tools like Puppeteer,
Yes.
right? Or like having the Chrome DevTools work. But also make them work very well and make the harness aware of them. So that, for example, the screenshots
That
are
that's the most
captured,
important thing.
analyzed,
Yeah.
and correlated with the plan and kept as evidence too. Right. Then, I mean, you can also check. Part of the plan, for example, is that when you are done, you have to write a section of evidence of which tests were run and where they are and such. And then when the file is written, there could be a hook, or there is a hook, that checks the file and says, hey, you mentioned tests. Do they exist? Let's look. The file exists. The function exists in the test. You didn't hallucinate that you wrote a test. Right? So that's still not perfect by book, because maybe it wrote a function that already existed. Right? But you're reducing chances with every deterministic test that you add. You are reducing chances.
That's true.
And it adds up
That's true.
because you attack it from different angles. Right?
Yes,
Like
that's
you did,
it's control.
like, and then you ensure that there is a phase that has a review, but
Mm-hmm.
then you verify that the review actually happened, and that it happened in a fair way, like without looking at. It's not the same agent that wrote the code. It's another agent that
Yeah,
verified the code. You can also
yes.
verify in the transcript that happened. And if not, you say to the agent, hey, you cannot commit the plan because of this and this. And then it will fix whatever it needs to fix and then commit. It will retry until it gets the plan committed. Right?
Nice.
And that's interesting too, because whenever the hooks tell it that something is wrong, that ends up being in the transcript of the session, right? That it, for example, that it retried 3 times trying to change the plan evidence, and the hook kept saying no, and it tried 3 or 4 times, eventually committed, fine. But then in the dreaming phase of the next dreaming phase, it will say, hey, why did you try 4 times? What's wrong with your instructions? So then it will create a finding and say, hey, maybe you tech lead approve changing this part of the skill so that it knows better how to write its evidence. So over time, its mistakes make it stronger.
That's exactly. It's part of the evolution of the system. Something that you mentioned, like it just keeps growing on our machine.
Mm-hmm. Yeah, it just makes it stronger. And we can see maybe that part. We chat. I'm going to put a chat window,
Mm-hmm.
and we can ask the system on that. Right? So, and that's the part that I wanted to invite our other guest. I couldn't make it. I think
Yes.
it was too late for his time zone.
Yes, I know right now it's almost 11 there. So
Yeah. So, uh, our other guest, Matthias, he has worked a lot with artificial intelligence and research on that, on medicine mostly. But he also wrote with another co-worker an architecture called CTE, right, which is the Cognitive Trajectory Engine. And what they did is a system which I also adapted the system to it, so that it knows how to do these dreaming things, right? And what it does is uh, close the loop, right? You have a loop where you are producing evidence, but then you need to feed that evidence into the AI to take it and to process it, and then produce the change needed to handle it and feed it back to the system. And the way it feeds it back is through a new plan, right, that is gated by a human. So that loop continues and continues, and it just keeps finding improvements. Right? It's called the self improvement loop. So we can see it here. Which is the what we call the CTE light. Here we go higher here. And this is an example of what I said about the screenshots, right? It took a screenshot that I gave it at some point, saying, hey, I saved this screenshot about this feature, and then analyzed the screenshots, and it put them inside the documentation. So I didn't know that this screenshot was here. But it's an example of the self-improving loop running. And then it does this, right? It has it emits, right, through here. There's an implementation. There's a plan. Then there's an implementation of the plan. Let's see if I can make it see better there. Then the implementation of the plan emits findings, and then the findings are analyzed, not just in the advisory files that the hooks emit, but also the sessions themselves are analyzed. It generates findings, which is where we saw the queue before. It consolidates them. This is the part that is called the CTE, because before I had CTE, it just made findings and findings and findings, and many were duplicated. So what CTE proposes is to consolidate it in a database that detects duplicates and prioritizes duplicates and so on. So after I did that, it did this, right? The consolidation, because it has them semantically indexed to be able to find duplicates and such. And then you end up with a clean consolidation of findings, which generates a plan, which the human approves, and it continues the loop. Right? So that type of loop, it can be done in many ways, right? Like I said, there's at least two that is doing to catch interesting data at the moment or later during session mining time, and then apply it. If we go back to, let's say, to the dashboard, and we say here, there, and we go to, let's say, if we can find these sessions, some of them are self-improvement, and there we go. We have done 56 in this machine that are self-improvement, right? And if we sum, let's show the sum of the done hours, but it's hundreds of hours that it has done by itself, right? It has figured out what to do, and then it has coded it by itself. So it's a fully self-implemented feature, right? Because normally the human is the one that drives the plan creation, and then the agent is the one that creates the code and everything else. But in this case, the agent is also creating the feature, the idea, and the plan. And that's really how the system has grown a lot, right? In the other machine, in my main machine, there's many more of these self-improvement plans. And it's a good problem, but
Mm.
I end up with a large queue of plans that I can execute slower than they arrive. And that's where maybe when the project becomes too large, you need one more person, right, to help you with that.
Yes, exactly. Yes, because it just becomes really large. Even with the AI era and all the agents working, some just one person cannot handle that much information. Maybe they can, but I can imagine in the long term just going to become exhausting, and
Yes,
that's why.
exactly. It becomes exhausting, and maybe as I get to improve more and more the how parallel sessions can work
Hmm.
independently. Right now, I still have many of those red gates where the human has to intervene.
Hmm.
So if I queue many plans and go to sleep, they
You.
actually continue working, but usually they advance in average 30% of the plans. But because some of them have dependencies on others, so they're waiting, but then they're waiting on a plan that stopped to tell me to change the model, and
Mm-hmm.
I'm sleeping, right?
Yes.
So I've worked on that actually, but I haven't used it that much yet because it's kind of recent. But in this view, sorry, we have a way to start a session directly from here, or to execute a session. Let's say I have a plan here.
Hmm.
They'll take one of them, and I could say run in a new session. And this, what it does is open a view that is just like Claude Code, where it's telling me, read this plan and execute it. And if I put OK, then everything, including the change of tires and everything, is done by the dashboard because it controls the window. And this one is fully automated. So if I were to start using that more, and I think it's time because it's now robust enough, I think, for that, then I could, start 3, 4, 5, 10 plans and then go to sleep, wake up, and they are done.
Nice.
And that's also another way to increase productivity because you are doing parallel plans, but you are also doing a code while you're sleeping. So you have 1/3 more productivity, right?
That's 8 hours dreaming and working.
Yes. And really you can get to 24 hours, right? Because there
That's
are many
true.
plans,
That's true.
especially if they are risk A, risk B, or you manage to pick the ones that don't have any human stops. Then, when the day finishes at 5 p.m., I could still queue them and have a coordinator agent tell it to execute them, and then they will be finished by night. And then before going to sleep, I queue some more, and then they are finished by when I wake up. And I now have 3 times more productivity than if I just worked 8 hours. So that also multiplies
That's a game changing,
productivity.
Mike.
One thing that causes is that you have so many plans in parallel that then in your head you cannot keep track of what's going on, and that's really where the boundary is, right? You have just too many things that you have to switch context between
Yeah,
agents.
yes, that's the
Uh,
main challenge.
yeah, that you can no longer control that. But yes, I mean
No,
that
no, this is great. So,
one thing that also I did that I found interesting is that if you guys have noticed, there is a cost that it shows here. And the reason for that is because when you're coding, you don't really know how much you're spending. And in here, this doesn't happen, because if you can see here, for example, as I'm coding, I have this bar at below that says what's going on. I'm using this model. It has 25% context usage, and it has spent $11. This is not part of Claude Code, right? All of this thing is an extra that is part of the framework. And as the turn continues, you see the dollars rising and rising. So you know that you are not spending $1,000 in a turn, right? Sometimes you're like, well, I'm not going to use Fable because I'm afraid that it will spend $100 in a turn. But here you start using it and say, hey, you only spent $5. So it helps you also see when the agent is spending too much unnecessarily, and you can stop it.
Yes, that's the thing. Yeah.
There's even some settings here that when it gets into certain boundaries of context or of dollars, you can tell it to pause just for safety, or to notify it. And it sends a push notification to your phone saying, hey, by the way, this session just reached $80. Want to check it out? And you can pause it. So the visibility of how much is being spent is great at the moment of working, but it's also great at the moment of measuring how the project is doing, right? Because you can say each plan how much money is spent, and then this plan came from the board, from this PBI, and then this PBI cost this much AI money to implement. But it had this business value. And you can start saying, hey, this business value very low, but you spent $200. And then you can also use that to learn to manage better the project, or how to code better a feature, or not code it. Because next time you know that little feature will cost you $200. It's not worth it. Or the other way, you have a super killer feature and you discover that it costs you only $20, $50 to implement. So it's more insight into how the project is doing, right? And well, the more insight you have, the better. And well, talking about insight, this is something that also when the framework or the harness is doing all of the typing, right, and also all of the screenshots and stuff, because it types the plans, it types the code, the tests, it does the gits, it does the commits, then you can control much more what's going on with the data, right? And what I mean with that is this part. If you go down into reports, right? I showed this one already, which is like how the repo is growing in its parts, right? But then you also can see how the plans are going, right? The reason there's no history before is because the system started doing this way of tracking in this week. So it's been this many weeks. And then the plan themselves have a classification. So you can see, hey, I'm doing this much feature, this much refactor, this much self-improvement, this much documentation updates, this many bug fixes. And then you have also. So this also tells you where you are spending the hours of coding, right? And these hours of coding, what the AI does is they are very precise, because when it does the plan, it estimates per phase what are the equivalent senior hours of coding of a human. So then it can know the total hours of the plan. But then it's not just a guess, because then when it finishes coding and it does the commit, there's a judge that automatically evaluates if the diff is equal to the hour estimation. right? Because a plan has maybe 4, 5, 6 commits. So it evaluates how much a developer would have taken to write that code per commit, and then it compares it to the original estimate in the plan, and it keeps track of that, and uses that data, analyzes it weekly to refine how it estimates the plan hours. And it has refined it so well that in the past weeks, it has been exact. Like it has been the variance. So in average, the hours planned and then the hours that came from the measuring the commits is the same. So they are well, like it gives you confidence that they are well measured, right? And then you can say, hey, yeah, most of the coding is features, right? Like a green wins, right? So it's like kind of healthy. But then you can also say, okay, let's look at the commit quality. So each commit, because it's done by the AI, it also has classifications, categories, effort levels. And instead of measuring hours, it measures effort, 1 to 5. And then you can say, hey, from the point of view of effort, where are we putting the effort? Right? Most of the effort is still features, but there is effort on trivial stuff, there's effort on bug fixes. And then, I'm not going to do it, but in the view, you can also view by user. So you can compare also. I mean,
you can have a graph of
say,
comparison
hey,
among
who
users.
is committing more effort? Because sometimes it's not just lines of code.
Yeah,
Right?
exactly. We are in a time that, well, in fact, it was never like a valid metric, like
It was never valid, but it's
beginning.
what you had.
Okay. But I mean, what you mentioned, the effort and the quality, now is, I think, it's more important given all the AI era.
Yes. And so really this is the effort of the agent, right? And you know what I mean? But you can also measure how much effort in volume each team member is producing. Right?
That's
And it kind of looks the graphic like the other one, if you look at the shape, but it's not the same. I mean, it's normal that it's correlated, right? Hours with effort. And it's also the same developer, which is me, so it's kind of average similar. But then we start comparing per developer, it will look different. Maybe a lot of hours of coding, but it's mechanical, so the effort is lower, and then this graph looks lower. Versus code that you are writing foundational with architecture and stuff, then it will put effort higher. And that it will look, when you compare the people, it will look also like that. Right? And then you can also measure, number of commits, also looks similar to the number of commits, but these are more the traditional ones, right? The interesting ones are these ones. You can measure commit quality and you can
nice.
measure plan quality, right? And now this is also something that is experimental right now, and is something that is not easy to put in a team just like that, because teams are sometimes measured in different ways.
Yes,
It
exactly.
could be misused, but it's there. And it's interesting to see, and it could give interesting insights, especially in those that are contributing the most. And then you have to maybe take care of those contributors in your team and help them too, right? So this is the system so far. We have talked already for what? 2 hours?
Almost 2 hours. Yes, 2 hours.
Yes.
That's quite a lot.
Yeah. I don't see much in the comment that we could talk additionally. You did make a comment, but I don't see it. Yeah, I see your comment here. But no, if anybody that is viewing right now can make a comment in the chat, you are welcome. We have, let me see if there's still people. Yeah, we have a bunch of people, more people still
Nice.
watching, but very few are commenting. So please feel free to comment if you want to see something else, if you are not thinking the same that we are thinking. You can also say anything about that, right? In the meantime, I wanted to show one more thing that is interesting, which is that, right, there's this chatbot that is really always anywhere, like here too, and it knows a lot about itself because has no drift between the code and the features and the documentation, but it also knows about Claude Architect Study, which is a study guide that Anthropic publishes, which is so that we as developers are trained on it. But really, the main reason of this one and of this other one, agentic engineering, is because the agents use it to teach themselves to do good agentic engineering. Like there is what's it called? A pedagogical layer in the agents that know what Anthropic or in general agentic documentation exists in the internet. There is a recurring task that knows where to look and pulls it into the repo. So the repo has a bunch of documentation about coding agentically or building agentic workflows or agentic systems. And that helps it even do better coding. Like sometimes I look at the Claude code session, right? And it says, hey, I'm gonna, while it's planning, I'm gonna think about doing it in a loop, right? Or doing it with a sub agent. But I'm not sure. Like it's a limit case. Let's look at what the teacher says.
Yes.
It asks the teacher, and the teacher looks up the relevant documentation because it has it very well indexed, and says, hey, according to the documentation, the best practice is to, if you have so much context, it gives it all the parameters. So the other agent refreshes its knowledge, or it has more specific knowledge, and it says, okay, now I think I'm going to use a sub-agent. So it makes a better decision. Right? And then that also gets mined, because during the mining, it notices that it went and it asked the help. So then it incorporates it into the skills. So then next time, the skill doesn't need to ask. And now the planning guard skill improved and incorporates that new rule into its skill.
That's great.
Right?
Like it's all the self-learning loop.
Yes. And that loop, one thing that happens is that as the loop runs, it starts modifying things. And it also has to keep like the skills themselves healthy, right? Because the skills end up growing and growing and growing. So it also knows how to like do progressive disclosure. Right? And it says, hey, this skill is too big. It notices weekly about that and says, let's break it down and let's put another empty file in a subdirectory, and in the index say, yeah, for this topic, go look at this file. And now the main skill file is much smaller, and that part is in a subdirectory. That process runs automatically, so all skills are always healthy. They will never contaminate the context window with a lot of stuff that is not needed at that moment, right? And that technique, I think is the last one that I wanted to mention, is that you do context injection. Once you have control in the harness of the entire process, and you saw how many points before in the SDLC diagram, how many points it has to, it knows what's going on, it can inject skills or knowledge just in time. And what's the advantage of that is that, like at the beginning, I only have like maybe 20, 30 skills, but they were always loaded into a new session.
Yes.
And that's the default. But in Claude code, in the front matter of the file, you can put information that says if the skill should be always injected, it should be available to the agent or just to the
Mm,
human. It has all those things. And so the system automatically detects and updates that so that only the ones that need to be injected are injected, which are really very few when you start a new session. But then when you start working, it finds keywords semantically, like, okay, let's plan this, or let's code this, or let's fix this. And it says, hey, you're going to fix something. I'm going to inject you with the skills that know how to investigate trace analysis, or how to use LangFuse. So the skills arrive dynamically as the developer is coding, is chatting.
mhm.
And that reduces a lot the usage of the context window, which costs less money and makes it run faster and makes it hallucinate less because there's less irrelevant trash that I will not use. The more irrelevant stuff there's there, the less chances there is that it will find the relevant stuff. So there's a lot of effort to only have in the context window the relevant stuff. And so that's like the biggest, right? I think one of the biggest ones because it reduced. Like I remember when I just started doing this, and it wasn't even an agenda existing, it was just a collection of skills.
Mm.
I would start a new session, and it was at 10% context, 15% context, and I hadn't done anything yet. And right now, when I start a session, it's at 0.2% context. It's like nothing. It's as if there's nothing on it. So that also helps a lot.
Yes, yes. Just by reducing the context window, it can help you to have like less hallucination in a single session.
Yes.
That's great.
So, and the one final thing that I've noticed recently, like because the system knows a lot about agentic best practices, when the report that it's building is about something agentic, which these days most things that we build are about agentic, right?
Mm.
It's not anymore just like an app or just a web. It's like something that has something with AI inside. Then it applies that knowledge to the repo and it builds better product.
Mm-hmm.
For example, it knows if it has to do a chatbot, it will know very well how to tune the loop. If it needs KB, it will do the graph. If it needs to inject skills, it knows how to inject skills. Do a harness, an eval harness, it knows how to do the harness because it has its own code, already has curated samples of itself on how to do it. So it just copies its code and puts it in the product repo. And that's something really great because it's like the templates and stuff are there.
Mm-hmm.
And
yeah, for future sessions.
And because it knows itself so well, because there's a big effort in the system that to know itself, it knows how to use that its own code very well, right? And it's there. The code is part of the repo. The system is part of the repo's files. So it just reads the files and uses it as a template or a sample for the product code.
Yes, that's. I mean, there is a lot of things to talk. I think. Now I want to learn more. So.
I think we'll keep talking. And last chance, I think, for the public to ask something different. But I think we are now over time, right?
Yes, yes. But it's has been a great session. Thank you, Sig.
I would
Thank you for
stay
sharing.
more really if people want, but I think people might also be tired of the session being kind of long. But still, welcome to ask things. And if we don't cover it now, I could cover it on the next session, maybe.
Excellent. Thank you so much, Sig, for everything. It was a great session, sharing all the knowledge.
Thanks a lot,
I
Carlos.
really enjoyed it.
We'll keep talking.
Yes, for sure. Yes.
Bye.